All right, so the last thing we're going to do in this section then is we're going to talk about the triple box product, or the triple scalar product. So what it is it's probably easiest just to show you guys this picture. But essentially, what happens is that we have three vectors, right? So we're going to have like this vector here, and this vector here, right? And we want to find then the volume of the parallelepiped that gets spanned by these three vectors, okay? And so how do we do that? Well, you see an equation down there. This picture's from a book, by the way. And let's pull it up. So the volume of a parallelepiped spanned by vectors u, v, w. What is this equal to? It's equal to the magnitude of u cross v dotted with w. Okay, so we're kind of pulling everything together. And so now let's take a look at an example. So let's find the volume of a box or the parallelepiped spanned by u is equal to 1, 2, negative 1. And v is equal to negative 2, 3, 0. Or negative 2, 0, 3. And w is equal to 0, 7, negative 4. And just to make sure you guys know how to translate right between ijk notation and this notation, this is I plus 2j minus k, right? This is simply just going to be 2i plus 3k. They're just going to leave the j out, okay? So if you see 2i plus 3k, remember to put 0 in for j, otherwise you're going to get this problem wrong, right? And then same thing with w then. There's not going to be an I term. This is simply just going to be 7j minus 4k. All right. So don't accidentally like translate this into the wrong thing, which is what I almost did here. So yeah. So be careful translating between I, j, k and these vectors. All right. Not said and done. Yeah. So it's the absolute value. Okay. So these are the absolute value signs of u cross v dot w. So why is it absolute value? It's because when you have a dot product, right, you get a scalar, and so when you see the straight lines around a scalar, then it has to be the absolute value, right? Like you can't take a determinant of a scalar. Well, I guess you can, but let's ignore that part for now. So okay, so one way we can do it then is we can just do the cross product. So here's 1, 2, negative 1, or what am I doing? ijk, 1, 2, negative 1, negative 2, 0, 3, right? And so this is going to be equal to I, 1, 0, negative 2, 2, minus j, 1, 3, negative 2, negative 1, plus k, and 1, 2, negative 2, 0. Right? Oh, I did this wrong. This matrix is wrong. 2, negative 1, 0, 3. Okay. All right. And then this is then 6i minus what? 3 minus 2. So minus j plus k. This is 0 plus 4k. All right. So this is 6, negative 1, 4. And now, so this is u cross v. Right? This is u cross v. And now what's u cross v dot w? Well, that's equal to 6, negative 1, 4 dotted with 0, 7, negative 4. And that's going to be 0 minus 7 minus 16, which is negative 23. All right, but we have to take the absolute value, right? So that's equal to positive 23. And that's going to be the volume of this box, okay? Big thing here, if you get a negative number, for the love of God, don't leave your answer as a negative number. I guarantee you on an exam, negative 23 will be a choice, like 100% guarantee it. And if you circle it, you'll get like half credit. Like, what are we doing? We're finding the volume, all right? It can't be negative. Like, please, this happens to people so much. I've TA'd this class 3 times. Every semester I get people coming in looking over their midterms, and they're like, damn it, right? It's just such a silly mistake. Don't make this mistake. volume, positive numbers. All right. So u cross v dot w is positive 23. All right. What's another way we can do this? Another way we can do this then, u cross v dot w, right, is actually just going to be, instead of doing ijk, what if I just put w in there, right? So if I did 1, 2, -1, -2, 0, 3, right? And then let's say I put 0, 7, -4 up here, all right? What do I get? Well, then I get 0 times 2, -1, 0, 3. So it's the same thing, except ijk just get, replaced. And then this becomes minus 7 instead of minus j, right? Because now it's the 7 that's getting canceled out. So it's a minus 7, right? Minus 7 times the matrix 1, 3, -2, -1, or the determinant of that. And then lastly, we cross out the -4. So then this is a minus, or plus a -4, okay? Plus a -4 times the matrix 1, 2, -2, 0. And what do I get? Well, I don't even have to calculate this first guy because that's just 0. This is minus 7 times 3 plus 3 minus 2, so that's 1. And then this is -4 times 0 plus times 4, right? And you notice it's the exact same thing we did above. This is 0 minus 7 minus 16, which is -23. And then we've got to take the absolute value of that, so that's positive 23, right? So notice these two methods, they're the exact same, except in the bottom method, right? So this was method 1, and this is method 2. And they're the exact same thing. So you might want to do the bottom method. It's faster. You just throw all three vectors, right? You'll notice this guy is w, this top guy is w, right? This second guy is u, and this guy is v. It actually doesn't matter what order you put them in. You could have done u then v then w in the matrix. So you could have done something like 1, 2, -1, v is -2, 0, 3, and then w is 0, 7, -4. It doesn't matter. You would have gotten the same thing. You would have gotten the exact same answer as you did here. So you can throw these three vectors in any order you want into a matrix. Take the determinant, take the absolute value. You'll get positive 23. Okay, so that's the quick way to do it. First way is just to show you why it works. And again, this picture, which I'll leave you guys off with, is what is the whole explanation. It's in your textbook right before the exercises start for chapter 12.4. Okay, so that's the cross product. The next section then is we're talking about lines and planes, probably the most difficult section in this chapter, but it really shouldn't be that bad once we run through it. And yeah, see you guys next video.